Hello my dear students, welcome to YouTube channel of eCareer Point, especially for English medium students. So how are you all? Hello Misty, I'm fine, thank you. So we have started this chapter, laws of motion, and this is third lecture. In first lecture we have discussed all the three laws, and in second lecture we have started the application of these laws. Hello Ankush. Okay, and also in this lecture we will continue with the application part of this chapter, laws of motion. See, laws are three that you already know from your previous classes, but in 11th class you are supposed to deal with the applications just like this. If you push this block, what will be the net acceleration and net forces on each and every block? So these kind of question you are supposed to answer in the exam, especially in NEET. Okay, so let's start today's lecture. So before starting, I want all of you to share this session to all of your friends so that everyone can take benefit of these free quota coaching classes on YouTube. Okay, provided by Career Point. So before starting, let me again introduce you to our toppers of NEET 2020. See, these four students are the toppers of NEET 2020, and they were our regular students and they were studying from eCareerPoint app. Okay, see, Vivek, Paras, Tana and Jatin, they have secured under top 50 rank. Okay, in NEET 2020, and the target batch of NEET 2021 has started with a minimal price, as you can see. And see, these students were the regular students of eCareerPoint. What is eCareerPoint? See, eCareerPoint is basically the coaching is CareerPoint, and the learning platform is on internet, so it is eCareerPoint. So you can easily install this app from Google Play. What you have to do, just search eCareerPoint without any space and you will see this eCareerPoint learning app. Just install this app and you will be able to use this. If you want notes of this lecture, the all thing that you are watching here, the things that I'm going to write here, if you want all these things as soft copy in form of PDF as notes, so this app is beneficial for you also. See, after installing, you have to follow your experts if you want the notes. After following, you will be able to attempt the question posted by your expert. Okay, and in this free stuff, you will get all the free notes. See, in free stuff, go to the medical section because I am teaching for medical, and here this class 11th physics NEET 2022 English medium, you will get all the stuff, all the previous video of previous lectures you will get here, and their respective notes. You can download it from here. Okay, so this app is very necessary. See, if you want to purchase any of our courses, we have both paid courses and free stuff. If you want to purchase any paid course, you can use this code ST10 to get 10% discount. Okay, and we are available on almost all the social media platform. And if any one of you is preparing for NEET 2021 and want to cover physics in 100 days, then you can join this course, complete physics in 100 days with a very minimal price. Okay, the contact details are given here and you will learn through this eCareerPoint app. Now let's start today's lecture. See, in first and second lecture, first lecture basically was the theoretical lecture more, in which we were dealing about the basics of laws of motion and what are the laws of motion. And in second lecture, the previous lecture, we have started this problem solving strategy, how to apply laws of motion in different situations. Okay, so let us recall all these points because we are going to continue that part and we will take some different kind of questions. Okay, see, first of all, what you have to do if you want to solve any of the question of laws of motion, first of all you have to make simple sketch of the bodies that you are going to consider. After making the sketch, what you have to do, you have to make free body diagram, which is also known as FBD. That means you have to show all the forces present on it. Then choose a coordinate system and resolve the forces into components. Okay, resolve the forces into components. Then assume the direction of acceleration of each block. After then, you have to use the Newton's second law of motion and frame the equation for the bodies. Then using this equation, you have to solve the equation for the required unknowns. So this is the simple technique to solve any of the question. So let me take another example to illustrate you. See, this is the question. The question says that we are having 3 blocks of masses 3 kg, 2 kg and 1 kg as shown. Okay, they are placed side by side on a smooth surface. A smooth surface means we are not going to consider any frictional force. We will study about friction force but later. Right now we are going to learn this without the presence of friction. A horizontal force of 12 Newton is applied to the 3 kg block, as you can see. Okay, and what you have to find? You have to find the net force on 2 kg block. So how to solve these kind of questions? In previous class, we were dealing with the bodies in contact with the help of a string. They were in contact with a string. But here, they are also in contact, but there is no string. Okay, they will move together. See, we are applying force on 3 kg block. It doesn't mean that 1 kg block will not move. No, all of these will move together. Okay, so as you can see, if I apply force on this 3 kg block, the 3 kg block will try to move forward. But the 2 kg block is in front of this 3 kg block. So it will oppose the motion of this block. Now, during this, what will happen? This 3 kg block will exert some normal force on 2 kg block so that it can also move. Similarly, at the same time, 2 kg block will exert some another normal force on 1 kg block so that 1 kg block can move. So all of these will move together with the same acceleration. Okay, all of these will move. So what we have to do, we have to make first free body diagram of all of these. Okay, and why 3 kg block is applying normal force on it? Because as I told you, normal force is a type of contact force. Whenever contact is there, whenever bodies try to penetrate each of them, the normal force appears, which do not allow this to happen. Okay, so first of all, what we are going to do? See, first of all, we have to make free body diagram. Free body diagram. Okay. First of all, I am making free body diagram of this 1 kg block. Okay. Let us draw first a sketch, then we will make FBD. Okay. Suppose this is M1, this is M2, and this is M3. Okay. First of all, I will use these variables, then I will put the values. So this is M3, which is equals to 1 kg. Okay, this is a rough sketch of this block. Then the second one, see, this is M2, which is 2 kg. Okay, then M1, which is equals to 3 kg. Okay, now we will make free body diagram. So be attentive, all of you. See, to make free body diagram, first let us assume this is the force F which we are applying on this 3 kg block. So on this 3 kg block, there is a force F which is equals to 12 Newton. This N stands for Newton, it is not for normal. Okay, so this is the 12 Newton force which is applied on this M1 block. How many other forces are there on M1 block? First of all, the earth will attract this M1 with a force of M1 into G, and from this ground it will have a normal reaction force in the upward direction. See, like this. This is M2, which is 2 kg. Okay. After that, what will happen? See, this mg and normal will be same, will be present for all. Not same, but will be present. For example, see, on M2 block, on this block, Earth will attract this block with a force of M2 into G. And it is not penetrating the Earth. That means Earth is exerting a contact force which is normal force. Why it is called normal? Because it is normal to the surface, perpendicular to the surface. So this is N2 force. Similarly, on this 1 kg block, the Earth will attract this 1 kg block with a force of M3 into G, and the ground will exert normal force N3. Okay, so these are the forces which we can see, but there are some more forces. See, when we push M1 in this side, it is trying to go in this side, but this M2 is present in front of it. So what will happen? To move, M1 will exert some normal force on M2. So M1 is exerting some normal force. Let's say this normal force is NA. M3 is exerting normal force on this 2 kg block. Now what is the value of this normal force? We will calculate, don't worry. So according to Newton's third law, listen carefully, if this M1 is exerting NA normal force to 2 kg, the 2 kg will also exert same and opposite force on this 3 kg. So this is the same normal exerted by this 2 kg block on 3 kg block. Okay, these are action reaction pair. This is action and this is reaction. They are occurring at the same time and they are on the different bodies. They are having same magnitude but opposite directions. Okay, now due to this force, M2 will try to move in forward direction, but this M3 is in front of it. So what will happen? To move, M2 will apply a normal force on M3. So on M3 there is a normal force. Let's say this normal force is N into not into NB. B is in subscript. So M2 is applying NB normal force to 1 kg. So according to Newton's third law, at the same time this M3 will apply equal and opposite force to M2. Okay, so on M2 the force is like this. This is NB. Is it clear to you or not? See, this is how we are going to apply Newton's law of motion in every situation. So we have made free body diagrams of each of these 3 blocks. Yes, we have made it. Now what we are supposed to do? Just make the equation using Newton's second law of motion and solve the equation. Simple. Okay, so for the first diagram, that is M3. For M3, if I write equation in y direction, see that this is not useful for us, so I am not writing the equation. I am only writing the equation for this x direction. And one more thing, all these 3 blocks, they will move together, so they will move with same acceleration a. So acceleration of this block is a, acceleration of this block is a. This black is showing the acceleration, which is not a force. This is the acceleration. So for the first body, as you can see, this normal is equals to m3g. Why? Because it is not moving in y direction. It is moving only in x direction. This is x axis, this is y axis. Okay, so for this I can directly say that normal force NB is equals to m3 into acceleration. Yes or no? Okay, so this is the equation of Newton's law of second Newton's law of motion in x direction for this m3 block. I am not writing the y equation. Basically n3 will be m3gy because there is no motion in y direction, there is no acceleration in y direction, and it is not useful for us because it is not asking any of them. Okay, now let us say this equation is 1. For this second diagram, that is 2 kg block, let us write the equation for x direction, Newton's law of motion in x direction. See, acceleration of this block is in this direction. That means NA is greater than NB. The net acceleration is in this direction. That means the net force on this block is in this direction. So NA is in this direction, NB is in this direction. What will be the net force in the direction of acceleration? It will be NA minus NB. this is the net force on this block in the direction of acceleration. So net force in x direction is equals to mass of the body multiplied by acceleration of the body. This is second equation. Is it clear to you or not? See, the main effort we have to make made in making these equations. So you have to learn how to make these equations by drawing free body diagram. Then after writing the equation, the calculation is simple. You have to solve this equation. So solving is the labor part. Mainly in physics, we have to learn how to make these equations. Is it clear to you how I made these equations? Let me know. Okay. So now time for the third one. That means for M1. For M1, as you can see, its acceleration is in this direction. That means this F force, which is 12 Newton, is greater than this NA force. Okay. So what is the net force in the direction of acceleration? It is equals to F minus NA. Why minus is there? Because it is in opposite direction. Okay. So this net force in this direction should be equals to mass of the body multiplied by its acceleration. Okay. Now see this. We have the value of NB, which is M3 into A. If I put the value of NB here, what will I get? I will get NA is equals to M2A plus NB, which is M3A. So it will be M2 plus M3 into A. Let's say this is equation 3rd and this is equation 4. Now listen carefully. If I use this equation of NA, what is NA? NA is the normal force applied between this M1 and M2. Both of them, they are exerting on each other. So if I put the value of NA here, what will I get? I will get F is equals to M1A plus NA. So it will be M1 plus M2 plus M3 into A. Let's say this is equation 5. Is it clear to all of you how I made these equations? Let me know. Use live chat. You can interact with me using live chat because you are watching me live. Okay. So one thing that we can conclude, that the net external force is always equals to total mass into acceleration. See, you have to learn to write this equation directly. How? See, if I consider only M1 as a system, then this is the free body diagram of M1. If I consider only M2 as a system, then this is the free body diagram of M2. Similarly, if I consider only M3 as a system, this is the free body diagram of M3. Okay. But if I consider M1, M2, M3, the combination as a system, then what is the net force on this combination? If I consider all the 3 blocks as a system combined, then what is the net force on this system? First of all, the total mg force will be balanced by the total normal force, and these forces, see these forces, these N2 is applying, M2 is applying on M1 and M1 is applying on M2. This is NA. Okay, and these forces, these two forces, which is NB, applying on each other. The internal forces will take no participation in the net force. Why? Because if I consider whole as a system, then on this complete system, there is no effect of NA because they will cancel out. I am considering this whole as a system, so there is no use of NA and NA because they are equivalent opposite. If I consider only M1 as alone, then this force is useful. If I consider all of these, then these two forces are not useful. So I can directly write that all the normal force are balancing all the mg force, and this is only the net force external. So net force is equals to total mass into acceleration if all of them they are moving with same acceleration. Is it clear to you or not? See, we have derived this thing on the individual level, and on the combined level we can write this. So what is the net force? Net force is total mass into acceleration. Okay, so I can write that, see, acceleration is equals to total force divided by total mass, m1 plus m2 plus m3. Okay, so acceleration will be, what is force F is 12 Newton. So it is 12 divided by, and what is this mass? 3 plus 2 plus 1. So it is 3 plus 2 plus 1. This is 6. 12 by 6. So acceleration is 2 meter per second square. See, we got the acceleration. Now the question is asking the net force on 2 kg block is. What is the net force on 2 kg block? The net force on 2 kg block is Na minus Nb. See, because we have calculated the value of this acceleration, which is 2 meter per second square, we can say that Nb is equals to m3, which is 3 into, no, m3 is 1. So it is 1 multiplied by acceleration, which is 2. So Nb is equals to 2 Newton. This N stands for Newton. Similarly, Na, which is equals to m2 plus m3. m2 plus m3, 3 into 2, which is equals to what? Which is equals to 6 Newton. Similarly, F is equals to 12 Newton. Okay. So what is the net force on M2 block? Net force on M2 block is equals to Na minus Nb. Okay. So net force on second block is Na minus Nb, which is equals to 6 minus 2, 4 Newton. So this is our answer. Or you can directly say that because the acceleration of second block is equals to 2 meter per second square, so net force on it is equals to its own mass multiplied by its own acceleration, which is 2 into 2. So answer is option B, which is 4 Newton. Is it clear? So this is how you are going to solve the questions related to this. Okay. Similarly, if I ask you what is the net force on M1, see, net force, suppose net force on M3. What is net force on M3? The net force on M3 is only Nb, which is equals to 2 Newton. So 2 Newton. And if I ask you what is net force on M1, net force on M1, what is this? It is equals to 12 minus 6, which is equals to 6 Newton. Okay. Or you can directly write, because all of them they are having acceleration 2 meter per second square, because all of them they are having acceleration 2 meter per second square. So net force on this 1 kg block is 2 Newton, which is 2 into its mass. Net force on M2 is mass into acceleration, which is 4. And net force on M1 is again mass into acceleration, which is 6. Okay. And to move all of them with 2 meter per second square, we need to apply 12 Newton force, which is total mass into acceleration. Okay. So this is how, if you practice, by practice, you will be able to imagine. Okay. I am doing this calculation, but there is no requirement to do this calculation each time. Okay. After the little more practice, you will be comfortable in solving this equation in your mind. See, without solving this, I can directly write now that total force, total external force on any system is equals to its mass and acceleration. And in the calculation of total force, we will not consider the internal forces. See, these Na and Na, they are internal forces. Na is having effect on M1 alone. But if I consider M1 and M2 as a system, then Na is having no effect, because on this system, Na is in this direction, also in this direction. So they will cancel out. Okay. Okay. Hello, Rinki. I think you are late. Try to come on time. See, I take classes on Tuesday, Thursday and Saturday at 3 p.m. So any one of you, if you are new in this channel, hit the subscribe button and press the bell icon so that you can get the notifications of upcoming lectures. Okay. I also take quiz, online quiz, in which you submit your answer using the online software and I show result on the board. So now time for the next question. See, this is the next question. This question says, this question is related to the previous question. Okay. So this question says, consider the following statements about the blocks shown in the diagram. Okay. That are being pushed by a constant force F on a frictionless table. There is no friction, so this table will not move along with them. Okay. The first statement is all blocks move with the same acceleration. Okay. See, this is related to the previous one, so you have to answer. All blocks move with the same acceleration. This is the first statement. And the second statement, the net force on each block is same. So you have to tell me then among these two, which of them is correct. Option A says that only A statement is correct. Option B says that only statement B is correct. Option C says both A and B are correct. And option D says neither of A nor B are correct. So tell me what should be the answer. Okay, beta, if you are new, just subscribe this channel and hit the bell icon. And try to be on time on class, because if you are live, you can interact with me. If you watch this session after the live stream, then you will not be able to interact. Okay, so Rinki is saying option C is correct. Let's see. As I told you, this question is related to the previous one. So let's see the previous one. Priyanshi is saying that option A is correct. Okay, good. Anyone else want to answer? See, you should answer, you should interact. Okay, because this is the process of learning. If you are getting wrong answer, don't worry. I will correct it. Okay, so this question was same as the previous one, so there is no need to do the calculation again. Okay, let us have a look on the previous one. But if this question comes in NEET exam, then you have to do the calculation. See, in the previous one, the situation was same. External force was there, M1, M2, M3 were the masses. Okay, and we have seen that because they all have to move together. We are exerting force in this direction. So all these have to move together. That means all of them, they should have same acceleration. So I can say all the blocks move with the same acceleration. Yes, this statement is correct. Now, statement B is the net force on each block is same. Net force on each block is same. This is the statement. Okay. So as you can see, what was the net force on M3? It was 2 Newton. What was net force on M1? It was 6 Newton. And net force on second block, it was 4 Newton. So net force is different, or it is very simple. See, because they are moving with the same acceleration. So I can say net force on, suppose this is M1, this is M2, this is M3. Net force on M1 is equals to, let's say net force on M1, I am telling F1, I'm writing F1. So it is equals to mass of M1, that is M1, multiplied by its acceleration, that is A. Similarly, net force on M2. Net force on M2, that means sum of all the forces, is equals to its mass into its acceleration, that is equals to M2 into A. Similarly, net force on M3, that is F3, okay, it is equals to its mass into its acceleration, that is M1 into A. Because M1, M2 and M3, they are different, so net force on each of them is different. Okay, so statement B is incorrect. Hence answer is option A, which says A is only the correct one. Okay, so don't worry, you are getting wrong answer, don't worry. This is the process of learning. Clear? What is the meaning of net force? Basically, net force means the total vector sum of all the forces on this block, on any block. Okay, and it is equals to mass into acceleration according to Newton's second law. So simple. Clear? Now, next question. See, try to solve this question by yourself and tell me the answer quickly. Two forces of 6 Newton and 3 Newton. They are acting on the two blocks of 2 kg and 1 kg kept on frictionless floor. What is the force exerted on 2 kg block by 1 kg block? Okay, so diagram, as I can see, it is missing. Let me show you the diagram. See, diagram is like this. Actually, these forces are horizontal. Okay, this is 2 kg block and this is 1 kg block. Okay, they are kept on frictionless surface. The surface is frictionless, and this force is equals to 6 Newton and this force is equals to 3 Newton. So what you have to do, you have to find what is the force exerted on 2 kg block by 1 kg block, or force exerted on 1 kg block on 2 kg block, because answer is same. The force which is exerted by 2 kg block on 1 kg block is same as the force exerted by 1 kg block on 2 kg block according to Newton's third law. Okay, Rinki, don't worry, once you subscribe this channel, you can see, just open this channel, and in the community post you will get the schedule. Okay, physics, chemistry and bio, all classes are there for 11th and 12th both. In Tuesday, Thursday, Saturday, the class is for 11th, and on Monday, Wednesday, Friday, the class is for 12th. Okay, so everyone just like this session and hit the bell icon after pressing the subscribe button. Okay, so this is the situation, and it is asking the force exerted by 2 kg block on 1 kg block, or the force exerted by 1 kg block on 2 kg block, because they are same. See, whenever we apply these kind of forces, as you can see, due to this force, the acceleration produced on both of them will be in this direction, because this is greater. So both of them will move together with the same acceleration in this direction. Okay. Now what you have to do, just make the free body diagram of each of them, apply the draw the forces and make the equation. Okay, so let's make free body diagram. Free body diagram for this 2 kg block. I am giving the names. Suppose this is M1 and this is M2, or let's write this as M2 and this as M1, because in that case M2 will be 2 kg, M1 will be 1 kg. That will be symmetrical. Okay, so this is what? This is M2, and this is M1. So let's draw the forces. 6 Newton force is applied on M2. So this is 6 Newton. N stands for Newton here. And 3 Newton force is applied on this. Okay. It will have M2 into G, which will be equals to normal force exerted by ground, N1. And it will have M1 into G, and this will be N2. Sorry, this is, let's write this as N2 and this as N1. Yes, N2 and N1. Okay, now what will happen? See, due to this force, M2 is trying to accelerate in this direction, and due to this force, M1 is trying to accelerate in this direction. Okay, so they will exert normal force on each other. M2 will exert, suppose normal force, let's say this normal force is N, only N, or let's say N dash on M1. So at the same time, according to Newton's third law, M1 will exert equal and opposite force on M2, that is also N dash. Due to this, both of them will have same acceleration in this direction. Okay, good Sahil, very good. So Priyanshi is saying answer is option A. Better think again, A is not the correct one. Okay, so this is a free body diagram. Let me know if you have any doubt in making these free body diagrams. Okay, first step is making free body diagrams. So if you can make free body diagram correctly, then only you can proceed. Is it clear to you why this N dash is here? What is N dash? N dash is the interaction force between these two blocks. Okay, this block is trying to move in this direction and this block is trying to move in this direction. So combinedly they will move in a particular direction, due to which, see, this M2 will exert some normal force on M1. At the same time, M1 will exert equal and opposite force on M2. Okay, so this is the force exerted by M2 on M1. This is the same and opposite force exerted by M1 on M2. Okay, and this is the force which question is asking. Okay, question is asking for this. This is the answer. So you have to calculate this. Clear? Now let us make the equation. See, first equation, we can make the equation for both of them, both of the direction. This is x-axis and this is y-axis. But y-axis equation is not useful for us because these blocks are moving in this direction. So n2 is equals to m2g, n1 is equals to m1g. We will not get anything from this. Let us make equation in x direction. We can say, see, the net force on m2 is in this direction because it should be in the direction of acceleration. Okay, so 6 minus n dash should be equals to mass into acceleration. So I can write 6, let me use another pen, this 6 minus n dash is equals to its mass, which is m2, into acceleration. Okay, so 6 minus n dash is equals to, what is m2? m2 is 2 kg, 2 into a. So this is our first equation. Now let us write equation for this, because they will definitely, both of them they will move together in the same direction. So what should be the net force on m1 if its acceleration is in this direction? Net force should be in the direction of acceleration. So I will say n dash is greater than 3 Newton. So n dash minus 3 is equals to mass into acceleration. N dash minus 3 is equals to mass m1 into acceleration a. Okay, now we have made these equation. Just write the value of this n dash will be equals to what? See, it will be equals n dash minus 3 is equals to, what is mass of first? It is 1 into acceleration. This is second equation. Okay, now add equation 1 and 2. Just add equation 1 and 2. If you add these equation, this minus n1 will cancel out this plus n1, and you will have 6 minus 3, which is 3, is equals to 3 into a. Okay, so what will be the acceleration? From this you will get acceleration is equals to 1 meter per second square. Okay, acceleration is 1 meter per second square. And you can also write acceleration directly. See, what is the net force here? Net force on this complete system, if I consider both of them as a system, then net force on this system is 6 minus 3. So net force, which is 3, should be equals to total mass, which is 3, into acceleration. See, we can write this equation directly. So we got the acceleration is equals to 1 meter per second square. Now you can use any of these equations to find the value of n dash, because n dash is the answer. They are exerting force n dash on each other. Okay, so if I use this equation by equation 1, see, or equation 2, equation 2 will be easy. N dash is equals to 3 plus a, which is 1. So n dash is equals to 4 Newton. This n is for Newton. Okay, hence answer is option C. It is asking the interaction force between these two. That means the normal force which they both are exerting on each other. So answer is 4 Newton. Is it clear to all of you? So some practice is required to solve these kind of question, and answer is option C, which is 4 Newton. Some practice is required, so don't worry, I will give you some questions to practice. Okay, you can download these slides as PDF, and how to download these slides I have told you at the starting of the lecture. How to download? You have to first download eCareerPoint app, and you have to follow your expert. Now see this, Next question. The elevator in the figure is descending with an acceleration of 2 meters per second square. See, this is an elevator, or you can say lift. In this lift, this is the block B, this is the block A, and the lift is having acceleration 2 meters per second square. That means both of them, they are having acceleration 2 meters per second square. Okay, the mass of block A is 0.5 kg. Then what we have to do? The force exerted by block A on block B is, or you can say, or force exerted by B on A, because they are same according to Newton's third law. If A is exerting some force on B, B will exert equal and opposite force on A. Clear? So what we have to do? Just make free body diagram. Simple. So let's make free body diagram of this A. FBD stands for free body diagram. So for A, this is A. Okay. On this block A, let's draw the sketch first, then we will draw the free body diagram. Okay, see, this is block A. The block A is attracted by the gravitational force, which will be equals to mass of block A into G, and there is a normal force due to B. Normal force is due to B, so this is the force N. Okay, now because B is exerting normal force on A, the A will also exert normal force on B. Okay, and B will have mg force also, m mass of B into G, and from the surface of lift there will be a normal force on B. Let's say this normal force is N dash. Now what we have to find? We have to find this value of N. That is our answer. Okay, we have to find this. Why? Because it is asking the block A, the force exerted by block A on block B. Force exerted by block A on block B, which is equals to force exerted by block B on block A. This N we have to find out, and acceleration of the complete system is given as 2 meters per second square. That means it is having downward acceleration of A, which is 2 meters per second square. It is also having downward acceleration of A, which is equals to 2 meters per second square. Okay. So write the Newton's second law of motion equation and tell me the answer. There is no use of FBD of B. Only by using the free body diagram of A you can calculate the answer. So what will be the equation? See, again we are going to take these conventional axes X and Y, and in this question there is no force in X direction, only Y direction force we have to use. And also here the normal force is not same as mg force, because the block is moving in Y direction with some acceleration. So for this block, because its acceleration is in downward direction, that means normal force is weaker than the mg force. So for Y direction we will say, because its acceleration is in downward direction, that means mg force is greater than normal force. So for this we will write the net force in the direction of acceleration, which is ma into G minus normal force, is equals to mass into acceleration. Now what is ma? It is 1 by 2. So 1 by 2 into G. See, it is asking the approximate value. So we can take G is equals to 10 meters per second square. Okay, because it is asking the approximate value. So into 10 minus normal force, which is the answer, is equals to again half into acceleration. Acceleration is directly given 2. Okay, so this 2 and this 2 will cancel out, and we will have the normal force is equals to, this will be 5, so 5 minus 1, so normal force is equals to 4 Newton. Okay, so answer is option B. Is it clear to all of you? Hello Rishi. See, those who are coming late, try to come on time in the live classes, okay? Because if you are live, you can interact with me using this live chat. Okay. So if any one of you is new, just hit the subscribe button and press the bell icon so that you can get the schedule of these free classes by eCareerPoint quota, especially for English medium students. Okay. Is it clear to all of you? Let me know. Is it clear? Right? Yes or no? Is it clear? Practice will make you perfect. See what happens if there is a table and a block is present on the table having mass m. Then the earth is trying to pull this block with a force of m into g. But it cannot penetrate the table, it cannot break the table, so the table will exert the force, normal force. Okay, and if it is at rest, normal is equals to mg. If table is moving in upward direction, in that case normal will be greater than mg if it is having some upward acceleration. Okay, if table is moving downward with some acceleration, then mg will be greater than normal force. Now, okay, good Rishi. Now see, if I want all of you to answer this, suppose this table is made up of wood. Now instead of wood, if I make a table of paper, suppose if I make a table of paper, very thin paper, okay, this is a paper, and suppose this is the table made from the paper, and from the ceiling, this is the thread, this is the thread, okay, from the ceiling, this is the thread which is holding this paper. Now listen, if I place a 50 kg block on this paper, on this very thin paper, what will happen? If I place 50 kg block on this very thin paper, this 50 kg block is having very high density, that is why it is very small. So what will happen? Will this paper sheet able to hold this block or not? This table is capable to hold this block. Is this paper sheet? Yes or no? What will happen? The paper will get damaged and the 50 kg block will fall. Why? Because this paper is not capable of providing required normal force. It is not able to provide the required normal force. See, if this is 50 kg, the mg force downward will be approximately equals to 50 into 10, that means 500 Newton. The paper is not able to provide the normal force which is equal to 500 Newton. No, but a rigid wooden table can. Okay, so this is how normal force is applied. Normal force has limit according to the material which we are using. Okay. So in this case, this A in the gravity space, it was supposed to fall with an acceleration of 9.8 meter per second square, or approximately 10 meter per second square. But it is not having that much acceleration. That means another force is present in opposite direction, which is reducing this acceleration. And this force is the normal force exerted by B on A. And similarly, at the same time, A is exerting force on B. Okay. Now, see, next question. By question only you will learn, because I told you in Newton's law of motion, in first lecture we have covered all the laws, and now we are required to solve the questions. See, a man of mass small m stands on a frame of mass capital M. He pulls on a light rope which passes over a pulley. This is a pulley. the other end of the rope is attached to the frame. Okay, it is holding the rope and the rope is attached to the frame. For the system to be in equilibrium, equilibrium means net force is equals to 0. If system is in equilibrium, that means it is at rest. What force must the man exert on the rope? It is asking the tension force in the rope. So how can we solve this? See, first of all, what we will do, we will make free body diagram. FBD, free body diagram. Okay, let us make free body diagram of man. This is man, which is holding the rope. Okay, and free body diagram of this frame. This actually these are the sketch. Now by applying the force we have to make. See, there must be some tension in the string and the tension force on this man is in upward direction. And the question is asking the tension force. Okay, tension force on this pulley in this side is in downward direction and on this side also it is in downward direction. In this frame it is in upward direction, on this man also in upward direction, and because the string is ideal, it is massless, so the tension at every point on the string is same. So the tension force on the frame is T, and this is our answer. Why? Because the question is asking what force must the man exert on the rope. The force exerted by man on the rope is the same as the force exerted by rope on the man according to Newton's third law. Okay, Rishi is saying option 1. Okay, good. Who is this English teacher is also saying option A. Good. Anyone else wants to answer? See, if you are new, hit the subscribe button so that you can get the notification of upcoming lectures. Okay, it will be beneficial for you if you attend each and every lecture live. Now, how many other forces are there? See, on the earth will exert mg force on the man. The man is having mass small m, so small mg on the man. And on the frame will also be attracted by the earth. So on the frame, capital M into G force is in downward direction. Now, one more thing, the man is standing on the frame. That means man will exert some force on the frame and frame will also exert some force on the man. Okay, man is, if I am standing on ground, there must be some force on me from the ground. Okay, so from this frame, the man is getting the normal force. And because the frame is exerting normal force on the man will also exert equal and opposite force. So normal force by man on the frame will be N. Okay, so this is the required free body diagram. Good, Rishi. So what we have to do, because they are at rest. At rest means acceleration is 0. At rest, acceleration is 0. Basically, it is in equilibrium, so F net is 0, that is why acceleration is 0. So I can say that this normal plus tension force is equals to small m into G, and here I can say this tension is equals to normal plus capital M into G. This is equation second, this is equation 1. So equation 1 plus equation 2. Add these equations and what will you get? Normal and normal will cancel out. You will get 2t is equals to small m plus capital M into G, which gives you t is equals to small m plus capital M into G divided by 2. Okay, so the tension force present in the rope is option A, and it is the same force that the man exert on the rope. Okay, so its answer is option A. Clear? So more you practice, more you will tend towards the perfection. And to practice, I am giving you some homework questions. Okay, this question is your homework question, and one more question I have given. So solve these questions and you will be able to understand the today's lecture. Okay, briefly. So answer is given. Answer is option D. So if you don't have this app, I suggest you to download this app right now because it is very beneficial. You will get all these notes which you can see here in this app only. Okay. After installing, see, first of all, you have to follow your experts, because if you follow, you will be able to attempt the question posted by your expert. And in this free stuff, you will get a lot of free stuff. Select medical, because I'm teaching for NEET. And if you want my previous lectures or my previous notes or these notes, go to this class 11 Physics NEET 2022 English medium. Here you will find the previous chapters also, motion in one dimension, projectile motion, along with the questions, and this chapter also, which is laws of motion, along with their notes. Okay. So if you are new, subscribe this channel. Okay, and share this session to all of your friends so that everyone can take benefit. Okay. There will be a time when I will take quiz on the topics which I am teaching. So all the live students can participate that quiz. So if you invite your friends, more students means more competition. So share this session. Okay. Like this session, all of you. And if you want to ask something else, okay, just let me know in the comment section. And how do you feel this lecture is? Is it good? Let me know in the comment section. Okay. So let's see you in, I will see you in next class, which will be on Thursday. Okay. Till then, thank you very much. This is Sumit Talwani signing out.